Hello everyone, it's that time of the year where everybody is thinking about what concentration to pick, and it is a difficult choice for a lot of students. So let's talk about the concentration in computational analytics today. I'm Dr. Amanda and I'm the director of the MSIA program, and I also teach some of the courses in the computational analytics concentration. So when you think about computational analytics, think about applying all of the skills that you've learned through your core courses, but also acquiring knowledge in specific areas within computer science, within data science, machine learning, as computer science approaches it. So here what we want to do is we want to give you knowledge, deeper knowledge in the area of big data and data science, and here you will learn about theories and algorithms and different techniques to apply for large scale data sets. And the goal here is to teach you how to develop models and analytical systems for a variety of different kinds of data sets. The cool thing about computational analytics, this concentration, is that it is domain agnostic. For example, the bioinformatics concentration deals with problems in biology. The health informatics concentration deals with problems within healthcare. In that manner, there is not one domain that will dominate computational analytics. Instead, what we will do here is to develop or to look at real world problems across different domains and to see how we can come up with data science solutions to solve those problems. So the reason this is absolutely exciting is in the tech industry and other domains, data science, the life cycle of data science to big data to machine learning and the intersection of all of these things is often required to take data and come up with innovative data products from that. So here in this concentration, the tools that we will use are Python, Java, Hadoop, MapReduce, Spark, and other machine learning libraries. The projects can range from anything with cybersecurity, image processing, text analytics, anomaly detection, such as using credit card data to find out what transactions are fraudulent. It really depends on the faculty teaching it, but we will explore a variety of different projects here. The kinds of careers that would be appealing to people considering the computational analytics concentration are big data engineer, data scientist, data manager, data architect, and of course data analyst. The concentration is made up of 3 courses. The first course is algorithm analysis and design. The second course is data science, and the third course is big data and machine learning. The first semester where you start your concentration courses, you're going to be taking the first 2 courses together. So you're taking algorithm analysis and design and data science together. And the next semester you will be taking big data and machine learning along with your capstone. This is of course assuming that you're a full-time student taking a full-time load. If you are a part-time student, you will be taking courses differently and maybe just 1 course a semester. Be aware that the algorithm analysis and design course and the data science course are offered in fall, and the big data and machine learning course is only offered in spring. So the first course, algorithm analysis and design, talks about different ways of designing and creating algorithms. So we talk a lot about the theory behind algorithm design. There are certain problems that can be solved using a greedy algorithm approach, and the whole notion behind a greedy algorithm approach is that every step of the way the algorithm looks at all of the different choices available and picks the best choice. That best is determined by whatever objective function you are trying to maximize or minimize. But there are other problems that are just not solved that way. You might need a dynamic programming approach to that, or something called a backtracking approach. So we talk about all of these different strategies of creating algorithms, and we will also talk about what problems are applicable to what design strategy. On top of all of that, we will also talk about graph algorithms. A lot of interesting data sets, a lot of large data sets in the tech world are graphs. For example, if you think about Facebook's underlying data, it's all a graph. So we'll talk about algorithms that can be applied for analytics on graph kind of data sets. And on top of all of this, when you have different kinds of algorithms, there has to be some way. For example, if I give you a problem and ask you to come up with a solution, you can probably come up with multiple solutions. But then there has to be some quantifiable way of saying this solution is better than this other solution. So that is where we come up with complexity analysis of the algorithms. So when you talk about complexity, what we are essentially saying is, as the input size increases, how much time the algorithm is going to take to run, how much space it's going to require. So we will talk about notations and ways in which we can quantify the footprint of an algorithm, how much space, how much time, and so on. So that course will talk about all of these different aspects. The second course is data science. This is an extremely cool course. So all of the theory that you've learned combined with more theory here will be combined with programming, so that you can actually apply all of those and create really cool solutions for some real world problems in this class. So here we will talk about data wrangling, munging, exploratory analytics, and visualization. We will work through an end-to-end data science pipeline. So looking at from the point when you acquire your data all the way to analyzing it, cleaning it, preparing it, visualizing the results, all the way. So you will have a lot of hands-on experience doing the end-to-end data science pipeline in this course. We will work with real world data, and depending on who is teaching the course during that semester, you will have partnerships with local companies. In the past, we have worked with Guilford County on some projects, City of Greensboro, Volvo, etc. We have established partnerships with them, and they have given us some problems and data, and our students have worked on solutions to those problems. The third course is Big Data and Machine Learning. Here we will go through big data definitions and characteristics. We will focus more on the computing environments for big data, managing that data and processing all of that data. We will learn about how do you scale up machine learning and how do you do online and batch processing. We will also talk about Hadoop, the distributed file systems, and MapReduce. Consider this concentration if you enjoy programming, and if you are not keen towards a particular domain. For example, you don't really think bioinformatics is a great fit, or if you don't think you necessarily want to learn about health informatics. If you don't have a domain that you're particularly interested in, this would be a great way to explore a variety of different applications without narrowing down to one particular domain. I hope this helps, and good luck.